Okay, well, let's get started because we want to stay to time today. First of all, welcome to our CHP Australia webinar series. We have done numerous of these webinars over the past 12 months, forced into it by COVID, but they've been quite well responded to, and we're getting great feedback on them, so we will continue them. So thank you for joining us today and participating. Today you'll be hearing about Blockchain 101. I've gone through the housekeeping rules, so I'll get right into the presentation itself. I'd like to welcome James Guild and Asim Salim from BCS Technology. You can see their logo on the screen as we speak. So James and Asim, we talked to them about doing a seminar today, and they said, well, how much detail do we go into on blockchain? And I said, I don't know the general knowledge of people in our industry, but why don't we call it Blockchain 101? And we may do a more advanced session down the track, but this is really about the basics of blockchain. And we then said, well, there's not maybe a lot going on in healthcare, but what might be some of the applications or what is being looked at today in healthcare using blockchain. So I think it'll be really fascinating. I'm really keen to hear about this. I'd like to thank James right now and Asim for your time in preparing for this and in sharing it with us today. And I will say, given it's hot topic of the moment, they're not going to give you Bitcoin advice to buy or sell or anything else, but they are asked that question a lot. Anyway, I would like to now turn it over to James. Thank you.
Thanks, Brenda. Thank you very much. Good morning, everybody. Happy to be here and really looking forward to, I guess, sharing some insights and context on a topic that I'm sure many of us have sort of come across in the media or perhaps in our roles, really to get an understanding of Blockchain 101. So thank you to CHP Australia for allowing us the opportunity to connect with your members. We really appreciate the opportunity. And look, I'm hoping this morning is really just about giving you a sense of, what Blockchain 101 is, and possibly some of the applications you could start thinking about. So, but I'll leave the sort of specialization piece to Asim. Just, I guess, in terms of a bit of an agenda, I'll probably just kick off with a bit of, many of you may know me. My name is James. I worked for many of the sort of healthcare organizations on this call and some other ones over the last sort of eight years or so in the ANZ region. And really, I guess I've recently joined BCS, and one of the reasons why I joined BCS was to really, I guess, apply some of the opportunities and I guess needs I was seeing in the healthcare industry, where it's really about the digitization of our industry. And this is, I guess, one of the parts of that journey. So there's a huge amount of acceleration, certainly in this sector, around how do we digitalize many parts of our business and what are the opportunities within that. And I've joined a business, I think, which is really at the forefront of delivering on those needs. In terms of our agenda today, I'll set the scene very quickly with a bit of context on BCS. Many of you won't have heard of BCS Technology. More from a point of view, just to give you a sense of, what is our capability and really our expertise. And then I'll hand over to my colleague, Asim, who heads up our blockchain practice. And really, I guess even has taught me a huge amount of information on blockchain in my few months journey at BCS. And he's really the right person to really lead this in terms of sharing his understanding and expertise. He's in charge of our blockchain practice and our emerging technology at BCS as a business, and he has extensive experience in this space. So he'll talk to you a bit about what it is very simply, a couple of thoughts around when it works, and then maybe some food for thought to take into your organization or to have a think about applications within the healthcare sector. So very quickly about BCS Technology, really, I guess we're a business that is an award-winning IT services business. And the point of this picture here is really to give you a sense of, well, we're operating in many global markets, and we have an extensive number of people in our business, all the way through from sort of, I guess, customer-facing account managers to highly skilled technical experts across the globe. And really what that means is that we're at the forefront of any emerging technology in any market, and we have the scale and skill set to adopt that and apply that in many organizations across the world. Our main goal, primarily, it's pretty simple. It's about how can we deliver IT solutions they're going to help your business grow your revenue or reduce your costs, so increase your profitability. And really, there's some specific customer outcomes that could be required. It could be about testing a new market opportunity. It could be about making process or connections and workflows within your organization much simpler. So we've got over 325 highly skilled technical people across the globe. And of course, within Australia, Sydney and Melbourne, there's a team of about 40 of us based locally. In terms of our customers, so we have a number of customers, and I guess the purpose here is really to show you we've got over 50 clients across our portfolio, and we're very proud of the fact that many of those have stayed with us for a long period of time, so more than 9 years, and we've worked on over 300 projects. And what this tells me really, and what it should tell you, is we've worked in all different kinds of sectors for all types of organizations. So really, if there is a challenge in your business around sort of technology or a solution that you're looking for, we've probably worked on it in some shape or form across the world with many of those clients there. We have a number of clients in the healthcare space. So Monash Health, we've worked with Health Metrics and Essity, which I'm sure many of you have sort of been following recently. They've just acquired Asaleo here in ANZ. We help them with their e-commerce platform. Simply, our solutions are sort of split into 8 sort of practice areas. And I guess the primary one is really around providing digital platforms for our customers. So that's where the software and platform development sits. That's anything from, we've built the Jetstar website and we're managing and maintaining that. We've built a number of apps, so WebJet, Discovery Parks. This is just local clients. So anything from a digital perspective, BCS is developing those platforms and I guess building them for our customers. And if required, maintaining and servicing those ongoing. And as with anything, you'd like to test any changes or any functional benefits that you could realize with some tweaks or changes to the technology. And we have an extensively qualified quality assurance testing team. So there's 2 ways really we run that, which is sort of manual, which is, we enact ourselves as a customer on the platform and make sure it's all working, or we can provide some scripted testing to do that on scale, which is obviously really important when you're a business like Jetstar and you've got a whole heap of people logging onto the platform and booking tickets at one point in time. Our practice also manages sort of cloud migration. So we work with AWS and obviously Microsoft Azure. And really there's 2 models there that we support, which is lift and shift from existing servers to the cloud, or we can create a whole new architecture as you migrate your business to the cloud, which is highly complex. You need a lot of skills in that space, and BCS has a number of clients that we've sort of moved on that journey. But we have the technology and connections with AWS and Microsoft to ease that journey. Analytics, a whole suite of options, and analytics is obviously one of my areas of expertise. And I think here it's really about, we've got that filing cabinet of all sorts of opportunities to work with many of you guys on, which is really around how do you coordinate, correlate all your data into one platform? How do we create some simple reporting all the way through to advanced machine learning? And one of the future topics we hope to be talking about is around analytics and capability in that space, a bit of a 101 on analytics. And then finally, not only do we do sort of the creation and I guess the build of many of those digital platforms, we also do some servicing of that, and think of this from the sense of, many of those platforms need to be run 24/7. So if anything goes down, we have the team to work on that. We have a contact center, which is really about using AI intelligence to support businesses around sort of customer needs. Innovation, we're talking about today within blockchain, although for us, it's sort of something we've been doing for many years, as you'll see from Asim. And then consulting, which as consulting sort of talks about, it could be anything from just a conversation around some thinking and workshopping all the way through to project management of any changes. So into blockchain very quickly. One of the things I think would be important to sort of consider when Asim walks through the 101 is, it doesn't have to be an end-to-end project that you could be considering. I guess our practice is set up to allow for a variety of opportunities or consultation points. You might want to just be having a conversation around what sort of business processes can we start to think about by using the distributed ledger, or it could be, hey, we want a thought to finish partners such as yourselves to walk us through the blockchain journey. And really, I guess having that flexibility has really helped us, in terms of our sort of profile being listed in the Gartner research around being a blockchain consulting and proof of concept development partner for the last 3 years running. So we've been doing that for 2018, 19, and 20, which really means, I guess, we've proven capability all the way from proof of concept to delivery across some of those sort of languages at the bottom. As I mentioned, our services cover sort of advisory and consulting. So really that's about, hey, we can just have a conversation about where we could deliver value in the process, considering some of the outcomes and expected success criteria. We could help identify an impactful proof of concept case study. So that's really about not necessarily going the full commitment level to blockchain, but actually looking for a proof of concept to share with the organization. Thinking about how you set up your network and the governance of that if you do explore blockchain, and then obviously about how you do some implementation moving forward. And then finally, I guess the final slide before I hand over to Asim is really around, I guess, the BCS capabilities. So I think Brenda said it nicely at the beginning. We've probably all heard about blockchain with Bitcoin and all the various cryptocurrencies. So on the left-hand side, you can see really, I guess, our expertise is, been centered in that financial services space. There's a high level of demand in that sector, certainly at the moment, across all sorts of things from contract management to commodity tracking. We've sort of worked in various forms and shapes in some of those projects, in fact, from end to end, with a number of sort of superannuation providers and a couple of banks within the Australian marketplace. We have worked on blockchain in other industries. So as you can see there, sort of in the middle to the right-hand side. So we've worked in occupational safety, which is really around management of contracts and creating tokens in that space. Supply chain provenance, which is really about understanding the movement of goods in the logistics chain. And here, I think for our industry, it's really thinking about, sort of counterfeiting and reliable products in the marketplace. That sort of blockchain analogy would work well there. Government, obviously, about record keeping and fraud monitoring. And then finally, in aviation, one of the sort of heartlands of BCS, it's about real-time reconciliation and creating of loyalty tokens in that space. So thank you for that sort of brief intro. I'll probably hand it over now to Asim to get into the meat of the presentation, to sort of really share with us what is blockchain.
Thanks, James. I was just trying to find my mute button. I'm audible, all right? Cool, perfect. Okay, so I think I'll have to go back one slide. Let me try and do that. Cool. So whenever we talk about blockchain, I think most people have heard about blockchain from the perspective of Bitcoin and all the cryptocurrencies, which has really made the technology popular. And there is obviously an intrinsic association with the cryptocurrency and the technology itself. And it's fair. But what I want to highlight in the very beginning is blockchain as a technology is not necessarily an incremental technology like what we mostly see. All of the other technologies which we hear about, whether it is cloud or AI or big data and advanced analytics, all of these are incremental technologies, whereas blockchain is necessarily a foundational technology. And much like how internet is, and like when I say internet, it actually even goes back to when the ARPANET, which is like the first connected machines, which was kind of like something which the US defense system was working on, and a protocol was designed to allow interaction between these devices, which is TCP/IP, and which later resulted in the formation of the World Wide Web, when the protocols for how these various devices can interact with each other and information can be shared using the URI, HTML, and HTTP, which are the protocols which are used for what we see internet today. Blockchain is sitting something similar. It still uses internet as a layer, but it's a foundational technology which allows, as opposed to how internet allows sharing of information, like between peer-to-peer parties. This is about sharing of values. Now, when I say foundational technology, what is it allowing? It is allowing the like formation of like very unprecedented business models which didn't exist before. Again, very similar to how internet did, where it changed how businesses were operating before. And it's like a good example of how we look at what internet changed is, if you look at how information sharing used to be before, it used to be in the hands of central parties. So you have information, and like there are multiple people in the room who have information about different things which they have researched, which they have known over a period of years. There would be a third party who will come and collate that information, put that into a book, call it encyclopedia, and then like actually sell it for money. Where as opposed to what internet enabled over many years is the formation of Wikipedia and like other forms of information sharing, where you can share information with anybody for free if that's what you choose to do. What blockchain is enabling is something similar, where it, in the context of value transfer, it removes the intermediaries, which are what we are used in terms of, when it comes to value transfer, we're used to having an intermediary enabling that. There are other forms of operational efficiency which the technology is enabling, plus obviously some changes in terms of how we think of what is important versus what is not, but more of that which is going to come. Now, I mentioned the internet and www for the World Wide Web, which is still like after 30-40 years, it's still something which is disrupting businesses. So if you look at blockchain, it's probably at that first stage, which is why I've pointed that arrow. It's still in that stage. It's still at that very beginning stage of the technology evolution, which is why, if you think of it now, it probably hasn't done much except for like Bitcoin, which has a hype, or all the cryptocurrencies which are a hype. It hasn't really done much because it's still very early stages and has a lot to go in before it really becomes the realizes the disruptive potential which the technology has. Now, let's quickly go into what led to blockchains, or rather the history of blockchain. You would have like, again, going back to foundational technologies, we took the comparison of internet, and even going back further, we know about electricity, which is again something which has disrupted the way humans do a lot of things. But what actually made electricity so common was one particular invention which somebody wanted to ensure that reaches everybody, and that's light bulb, right? So when Edison wanted everybody to like have light bulb and buy light bulb, that's when electricity really took off. But electricity is the underlying thing which enables it. Similar to that, if you look at the history of blockchain, which led till the point of Bitcoin, which is when it became popular, it was necessarily something which has been happening for over a long period of time, around innovations around many technologies which were being tried to solve one problem, which was how do you digitize cash. We traditionally have always had a cash as a physical asset which was being transacted with, and there is a reason why cash is always been physical, because cash by itself has a few properties which we want to maintain. One of it being like the anonymity, and then the second one being the acceptability of that particular asset. And then there are a few others, it being portable, durable, like divisible, etc. But that's one of the reasons why cash has been so difficult to digitize, as opposed to if you look at money, there has always been a digitization which is happening on the debt side of it. So you could always digitize debt because there is a record that I'm like taken a loan from somebody, and that debt is the one which gets transferred. That is easy to digitize. Cash, on the other hand, has been very difficult to digitize, and that attempt has been going on for a long time, and which started with I think it's like around 30 years back. There were the use of a few different technologies which was being attempted. One is the concept of using the concept of cryptography to sign signatures and then kind of assign ownership to a record which has a value which was used to transfer, to then using a digital ledger where the transactions which were having between people were being linked using a timestamping methodology, where every transaction is linked to the previous transaction, and it maintains a history of all the transactions. Now, all of this had a few problems. There is still a dependency on the intermediary to provide those services. So whether it is like the signature verification service, whether it is the saving of that time-stamped ledger, all of this was dependent on a third party providing it as a service. Whereas the need for a digital money is for it to be peer-to-peer. Right? You don't want a centralized authority having that information. You want to do it peer-to-peer, just like you would do with currency, which you like. It's a paper. Once you have it, you can decide whom to give it. It has uniform acceptance in terms of value in the network which you operate, which is probably like within the country which you are in, or even globally. If you have a piece of gold, you know that you can walk into anywhere and then can kind of it'll have a value which you can use to transfer or purchase anything. So that's the kind of digital equivalent which is being attempted. So the other issue, even when all of these different concepts came together, along with the peer-to-peer like information sharing technology, and if you've done a little bit of file sharing and all in the past, you'll know like peer-to-peer data sharing has been around for a while as well. So there is a protocol which defines peer-to-peer data sharing. But how do you actually bring trust into that network, especially when it comes to transfer of value? So one, the trust in the network, and second, the concept of what is the mechanism where a dispute, or like if there are two people claiming same transaction to have happened. So I have, say, a value like a particular token, and I'm saying that I've transferred it to this person, and there's another claim that I've transferred it to another person. How do you determine which one is the right transaction which is accepted by the network? So what is the protocol around that? Those are the two missing points which Bitcoin kind of resolved. So what Bitcoin allowed is it created, it built on all of these various different technology advancements which has been happening in that space over a long period of time, and brought it all together using a concept of a incentivization mechanism, which is called as proof of work, where you make it difficult to create transactions in the network. So which means it cannot be spammed, and you need to put some effort in terms of like resources into it, which means you wouldn't just do it for the sake of it because it is costing you some money. And the second is there is some rules around what transactions gets accepted, and for the people who are putting that effort into linking these transactions gets incentivized in the form of an equity in the in the system, right? So, and which is what is making them actually keep the network safe. Now, that's what led to blockchain. So when we got to the point of Bitcoin, what everybody realized is that it is not just about a cryptocurrency system. So it does, obviously, that is the first instance of where it got applied. But this combination of technologies which led to what Bitcoin was utilized can be used for other sorts of value transfer as well, building on the same principles. So which is why Bitcoin is much like, the light bulb, where it is allowing a new protocol to emerge in terms of that value transfer, as opposed to being the main core of the technology. It is not. It's just one of the use cases of the technology. So let's look at. Yeah, let's look at a little bit about Bitcoin and other cryptocurrencies. So these are what I call a single-use stage of the technology itself, right? So it solves a single purpose, which is peer-to-peer transfer of value. It's built on the foundational concepts of cryptography, decentralization, peer-to-peer networking, and like in a transactions occurred on a ledger. What it enables is a community. So it enables the creation of a network which accepts whatever is being transacted as value within that network as something which has real world value, right? So that it's the network which keeps that whatever is the asset within the network in having value. Outside of it, it may or may not have value, but within the network, it has value. So if you think of, say, Bitcoin or Ether or any of the other cryptocurrencies, within that network where it is being transacted, the network participants believe that it has value. And that value is kind of fixed and it's uniform and all. When we look at it from an outside perspective, that value might fluctuate, but within that network, that value is constant. So it enables that community, and then it defines a system of working, which is called as the protocol. How do you transfer between peer-to-peer? What is the mechanism in which the ledger is updated? These kind of rules that is defined in the protocol, much like TCP/IP was a data transfer protocol. Here it is a value transfer protocol, and the protocol consists of how the ledger gets written, how it's stored into a distributed ledger, plus how does consensus get achieved across the various participants in that network. Now, Bitcoin uses proof of work. There are other networks which uses other concepts around consensus, but in any stage, there is some sort of effort which is required, or like if it is not effort, when I say effort, it is in the form of computational capacity, which you will hear a lot. But the other aspects, like other protocols, uses equity in the network. So you need to have some sort of investment into the network for you to be validating transactions. So there are like different ways in which that is achieved, and for doing that, you are rewarded in the form of further equity in the network. So I think there's a question which came through about whether it is possible to hack blockchain transactions. Technically speaking, it is, but that's the beauty of the system, right? So the reason for like the ability to hack a blockchain network is only if you are able to take majority control of the network. So like if you have 51% control of the network, which is quite possible, like if you have a lot of money and you buy up every single node pool in the network, or like build as many node pools so that it forms more than 50% of the network, you can hack the network. But what you have done all that, you have invested that much money into the network, and if you are making changes, that immediately drops the trust in the network, and then that network becomes useless because nobody is going to use that network anymore. So which is why that consensus mechanism is kind of ensuring that whoever has control over the network also wants to ensure that the network stays trustworthy. Otherwise, the inherent asset, which is what they get as a benefit of managing or running the network, stops having value. So which is why this worked as opposed to all the other mechanisms which was tried in the past to have a digital currency. Didn't work because yes, there was the ability to hack and take away value without anybody noticing. But here, it's the incentivization is not in the form of an external currency, or it's not in the form of being able to fool others, but it's an open ledger. Everybody can see that there is some sort of a hacking which has happened, and then immediately it stops having value. So people wouldn't attempt that. That's at least the idea. Have it happened in the past? Yes. At the initial stages of blockchain, at the initial stages of Ethereum, there has been instances of like a 51% attack, which has happened when it was like still low in value, but the chances of it happening now is very, very low because of the amount of people who are maintaining the network at this point of time. So that's a little bit about Bitcoin and like that, the first use of that blockchain protocol, which we were talking about. A few years into Bitcoin came Ethereum, which builds on the same concepts of Bitcoin, which is enabling the concept of the transfer of value between the different peers. And what is recorded is the transaction, the history of transactions across all the different participants in the network was basically the principle. What Ethereum did is build on top of that and said, okay, we do store the history of transactions, but what we want is also to mimic the real world where transactions are not just triggered by one party. So it's not like I transfer something to another person, the person transfers to another person. That's how the transactions are recorded. There has to be some sort of logic built into automating some of these transactions to happen. So there has to have a programming layer on top of it where some of this logic can be written. And then it is not just the transactions which is maintained by the various participants in the network. It has to be a state which consists of the transactions, the ledger, as well as this programming logic. So together, combined, instead of a distributed ledger, Ethereum is a distributed state machine, which is similar to like if you like are familiar with programming, you have like a virtual machine, a Java virtual machine running in on top of which you write your programs. This is like a Ethereum virtual machine, which is a state machine which is distributed across all the participants of the network. Now, what this enables is like moving away from the concept of Web 2, which is where like internet kind of enabled a lot of different services to come into picture, which was centralized around one party having a lot of control. Take Twitter, for example, Facebook, all of these are, and like Uber, all of these are examples where a centralized party actually tapped on a peer-to-peer kind of service, but then by providing the platform where that service to happen, they kind of became custodians of the data sharing or the value sharing between those two parties, whereas Web3 allows similar services to be happening without having that central authority. However, a network where there is a common set of rules which are defined, and what the like Ethereum-like platforms allow is the mechanism where those rules can also be codified. So what is, if we are looking at Airbnb, for example, if there are going to be people who are putting their houses for rent for a few days, what are the conditions in which they can have like that rental platform, and that logic is going to be sitting in the network in the form of smart contracts, which, and like ignore the word smart in the smart contract, but pieces of code which all of the people in the network agrees on, as opposed to like a central party like Airbnb saying that, oh, this is going to be the set of rules using which you can like rent out your house. That's the concept which it enables. So that's necessarily an evolution in that whole concept of blockchain and what it is allowing now. Obviously, at this stage, there are a lot of challenges in terms of scalability because of the fact that it's still built on a proof of work kind of logic. It takes time. Each transaction takes a lot of time for it to get completed and accepted in the network. All of these are not really ideal in terms of being still disruptive, but that's where the version 2s of blockchain, version 2 of Ethereum, and similar networks like Polkadot, etc., is coming, where they are trying to address some of the issues which the current version of blockchain technology or the distributed ledger technologies have. Now, at the same time, if you look at how technology evolves, it always starts with a single-use kind of scenario. Like we say, like currently for a blockchain, it is like Bitcoin was a single use which started everything. The next stage of evolution is actually the localized usage of that technology. So if you look at internet, and again, I'm like, internet is the parallel which has been used for blockchain technology, so I'm sticking to that. If you look at internet started with like, information sharing, but then the second evolution of internet was the formation of intranets, where a few people just wanted to use an equivalent of internet within the net, like within themselves, and not necessarily connect to this big, like large internet. And that's what we are seeing in the form of private blockchain networks being formed, where a lot of the same concepts are being applied without having that concept of a huge network or node pool to support, where information is shared across everybody, right? So you basically keep it private. Obviously, it loses some of the aspects of the technology itself by doing that, because like the whole power of blockchain comes from the trust in the system, that it is not hackable because of the large number of people who are interested in the network and trying to maintain the network. However, when we're looking at private networks, you assume that it is a fairly trusted parties who are running that network, so you don't have to worry so much about bringing a technology-based trust or like an inherent protocol which defines trust. It is the familiarity which is bringing the trust. People assume, or like this is the what is being told, that similar to intranet, it eventually is going to die out and everything is going to be part of the big large public networks, and probably with the advancements of some a little bit more about anonymity, which can be included into the transactions which are being written into the public network, which is probably the reason why a lot of private networks are being used now, because you don't want all your transactions to be visible to, say, your competitor, etc. So you want to deal that privately. But once those limitations are addressed, which are already in the works by the various protocol providers, that should be the direction where it goes to next, or at least that's the assumption. So with Ethereum, that is level 2 now. With that, let's quickly look back into at where we stand today. What are the key pillars of the technology? So at the heart of it all, there is a distributed ledger, which is recording transactions and maintaining a history of the transactions in the form of a single ledger. It uses a few different technologies to be able to record that many transactions without taking too much space, which I'm not going into too much into detail. It has some sort of a consensus mechanism, which is an algorithm which allows the how the updating of the records can be allowed within the network. Proof of work being what is used in Bitcoin and other consensus mechanisms exist in some of the newer networks. There is an encryption mechanism, which is a public-private key encryption, which like most of you must be familiar with, where like the person who is writing the data is publicizing their public key, which is used to encrypt the data, but then to read it, there is a private key, which is not available to the other parties unless they have specifically allowed another party to have access to a particular transaction. And smart contract, which was introduced as part of Ethereum, which is self-executing agreements. So basically just a piece of code which will get triggered on a particular condition, which can be related to how a transaction is occurring. So if this transaction occurs, it reaches this particular condition, then trigger this, is what smart contract does. And immutable audit trail, because of the way the transactions are blocked together and saved into that distributed ledger. There is an audit trail which cannot be changed by like a database admin, for example, cannot go and edit it, because that kind of breaks the whole ledger and will make the whole like the platform unworkable. So that is something which is not possible, at least in the form of a public blockchain network. Now that's blockchain technology. There are variations of this, right? So from an enterprise perspective, there are variations of blockchain technology which doesn't use some of those concepts. Say, for example, a lot of the enterprise blockchain protocols, like the main ones are Hyperledger and Coda, has made modifications of some of this to suit more enterprises who require slightly different functionalities. For if you look at Coda doesn't maintain a concept of a block at all. It is purely a state machine which transfers which keeps a record of the transfer of states, and without using a concept of a block at all. Hyperledger uses a similar concepts, but then has another layer where transactions can happen privately between party to party, where it is not actually recorded between the other parties who are not part of the particular transaction. There are various ways in which this has evolved to suit different use cases, but at the heart of it, that kind of is like the main parameters of blockchain technology. Where is the fields of applications of blockchain technology as we see it today? First and foremost, it is still mostly applicable for the financial services industry, where the value, the asset of value which is being transferred is a monetary asset, so similar to Bitcoin, or it can be any other monetary asset which is being transferred, which is allowing direct transaction between parties in the network using that particular asset. What does it allow, or what is the incentive? For organizations to look at it: optimization of cost. So the cost which goes into intermediaries to enable that as a service, which they do today. Reduction in fraud because of the fact that it's being actually maintained by everybody in the network. And then like the security of the transactions, the difficulty in terms of being able to go and change transactions from a fraudulent perspective. Those are the benefits. Now, financial services, while a simple money transfer is what kind of triggered this whole thing with Bitcoin, but there are a lot of initiatives happening in that space. You would hear a lot about it, called as decentralized financing, which is enabled by that programming logic which Ethereum brought into it, where micro lending and investments and all are being enabled on top of the network using some sort of a monetary asset, which kind of allows that. And yeah, we can go into detail on that later if interested. The other area where the blockchain has an application is in supply chain, where it is actually a physical asset which is being transferred, and a digital equivalent of that has to be tracked. So not necessarily you can kind of control the physical asset into the network, but you can actually create a digital twin of that and track it in a blockchain network, which allows for increased traceability, data verification, redundancy of data, etc. And there are a few others, like two-sided markets. We spoke about Airbnb likes. That's an area where a lot of disintermediation, cost optimization, risk decentralization is happening, and in the form of social welfare, where the asset can be anything which is specified by the user. E-voting, for example, and electronic health records, etc., are areas where there's a lot of work happening and using blockchain for that particular field. And where is blockchain, quickly talking about blockchain for the enterprise, where is it actually impacting the enterprise? Immediately in the near term, just awareness of the fact that, similar to how internet kind of disrupted a lot of business models, there is this technology which has potential to disrupt the way the business works today. While that is not going to happen today, being aware and being ready for disruptions to happen in that space. The second is the fact that there are networks being formed which is starting to accept a different sort of value transfer, and which might be something which you have to integrate into. So it could be just the fact that allowing, if people want to say use Bitcoin or something else as their record of value, at some point of time, it might be something which has to be enabled as part of your business as well. And it's unavoidable. Not saying that Bitcoin is going to be that value transfer, but at some point of time, there would be one which has more wider acceptance, which is going to emerge. And then at that point, how do you enable that? And the other is, are there inherent benefits in looking at the technology in your network? So that private network where optimization in the way you do B2B data or value transfer can be improved is one area which probably can be looked at, is where the enterprise should be looking at blockchain at this point of time. And then there's other areas, but that's probably like really long and far away in the future, where it really is going to have an immediate impact for your business. So when is blockchain disruptive? It is really disruptive when there is data sharing happening across multiple parties and touch points, and like, the parties who require and collect, store information across multiple parties. And if the business model is like that, then blockchain is a compelling value proposition. Why? To complex, like reduce the data reconciliation requirements, which is probably existing, and like you have a lot of errors happening because of centralized data storage and like happening in multiple levels. That's where blockchain becomes really disruptive and a compelling value proposition to look into. Since we are like talking about healthcare, where is the applications happening in the space of blockchains? Primarily in 4 different areas. One is in like the patient health record, like the sharing of that information, giving control to the patients to to determine who has access and who doesn't have access, and using that power of the patient to then enable clinical trials and health research and etc., using some sort of an incentive mechanism where that sharing of information is incentivized in the form of micropayments, which is enabled by networks like Ethereum, etc. And then there is the drug supply chain integrity is another area where a lot of work is happening. And the last bit is just claims management, where a network like that can automate a lot of the processing which goes between multiple parties, especially when it comes to claims management, reducing the number of interfaces or number of manual interventions required where processing happens, is the 4 areas where a lot of work is happening on the healthcare industry. You can see there are, like, I've just listed a few of the startups who are working in that space. There are many more now. And I think one of them, Medrema, is Australian based as well. So quite a bit of work happening in that 4 specific areas, which is trying to obviously disrupt the way how that industry is working. So that's like at a high level some summary of technology, as high level as I can keep it, but I'm just probably opening it up to any questions which you have in the next 10 minutes which we have, and I can go specific into those details.
Mm-hmm. Okay, thank you very much, James and Sim. The first thing I'll say is, if that's 101, I can't imagine an advanced course, because I'm still trying to absorb some of the things you said, but thank you. I think very well put. I think someone sent through a Q&A saying, yes, very clear. So thanks for that. I have been texted a few questions. I'm not sure why it came through on text, but anyway, so let me I think we've got a few minutes left.
Sure.
So Asim, you talk about light bulbs being the item that launched widespread acceptance and use of electricity. Is cryptocurrency the light bulb item for blockchain, or do you see another application leading to wider acceptance and use of blockchain?
So at this point of time, I would say cryptocurrency is definitely the light bulb which is triggered that I wouldn't say acceptance, but at least widespread interest of blockchain as a technology, because all of these concepts did exist for many years back. It's not something which didn't exist before. It's only because that all of those were converged into the use of a cryptocurrency, and then everybody is talking about cryptocurrency, that even like enterprises are looking at this combination of technologies in conjunction to look at how can we solve some of the problems around, say, B2B data sharing, B2B value sharing, which wouldn't have happened if not for the cryptocurrency triggering it. Now, I know cryptocurrency has a lot of negative connotations and like what it is being used for. While that stays true, that's human nature, but there is an application of technology which is being triggered by that interest, which is being funded by that interest. So, I would say it is comparable to that.
Okay, great. I'll keep going here. On the healthcare comments, you mentioned drug supply chain integrity as one of the potential applications. Could this be used to substantiate advertising claims that relate to the provenance of a product, for instance?
Yeah, absolutely. Absolutely. So again, one thing to keep in mind is with supply chain, there is a factor which we have to really understand, that unlike the financial assets that you're talking about, there is a physical asset. So what we can only enable is the digital representation of that asset. So there is always an underlying assumption that that match between the digital asset and the physical asset is trustworthy. And that's something which blockchain or that technology is not going to be able to really address. So provenance, yes, it absolutely can provide that provenance, but once it is converted into a digital format, there are other technologies which allow that link between physical and digital, like IoT, for example. And IoT is a great, the other way, blockchain is actually a good advocate of IoT, because some of the problems on how would IoT become viable is addressed by blockchain by allowing that micro transactions. You can, if you're transacting value using a digital asset within a blockchain network, then you can allow for micro transactions. And that's something which to be kept in mind. You'll see blockchain and IoT working together a lot. But yes, provenance is definitely something which is going to be enabled by blockchain.
Okay, and I think I've got time for maybe two more. Okay. Someone said, I want to explore the apparent tension underlying the concept. On the one hand, one of the aims of blockchain is to remove the centralized authority, lack of trust in a central authority. But on the other hand, as you said, trust in the network is critical. So how do you see these being reconciled?
Yeah.
Is it just the size of the network, or?
Yeah, absolutely. So there are two parts to it. So one is the size of the network. So the number of nodes who are custodians of the network, the more difficult it is going to be able to fraud or take a control of a big percentage of the network. The second is the point of what is inherent, or what has to be looked into how a network protocol is defined, has to be around that concept of incentivization. How is the incentivization built into the network that the participants of the network don't want to really make it negative, or rather create fraudulent transactions? Because if they are incentivized in a way where, or rather de-incentivized in a way, if they do that, then the network value goes down, then it wouldn't happen, right? Because what is the value in I kind of trying to dig my own hole? So because what is feeding me, I'm cutting off its own arm, kind of So that's the incentivization, and that's probably the biggest success of Bitcoin over everything else, because it wasn't something which was thought of earlier on how do you eliminate that by incentivizing the network participants using a value system which is within the network itself. So which is why the miners in the Bitcoin network get paid Bitcoin itself. So if Bitcoin doesn't have value, then all the effort which they've put in to get that Bitcoin is going wasted.
Yeah. Okay. And just based on that, because you mentioned also, again, someone talked about a controller of the network that you mentioned. So someone could control 51% of a network or whatever, unless I'm interpreting it wrong. So yeah. Could they replace the centralized authority, because they become the dominant,
Oh, absolutely. So if there is a particular participant controlling 51% of the network, they can become the dominant authority. But it's just this is actually, there is nothing stopping from the other 49% from going and creating their own network if that happens, right? So that's pretty much the concept. This is open source. There's everything which is enabling that network to work is something which anybody can kind of use. So what would typically happen is, if somebody, you can see that somebody is dominating the network, the value interest in that network goes down, new networks start popping up for doing the same thing, and then obviously the first one, which is controlled by one person, is not going to have much of an interest anymore.
Yeah. Okay. And very quickly, the other 101 course I'll do one day is quantum computing. Someone's asked, will blockchain be a redundant technology in the future with quantum computing? Is there any relationship, or they're two different?
No. So in a way, yes. So I think the concept came about where we were talking about proof of work as one of the first consensus mechanisms, where the network is making it difficult to make that linking of transactions, because it's computing power which you have to put into to determine how that linking is done. And that's the incentive which is used to like stop people from randomly trying to make their transactions accepted. So there is some effort going into it. Quantum computing is going to affect that, right? So proof of work as a consensus mechanism is going to go redundant because of quantum computing, because it will be very easy. So there won't be much effort or work which will be required into doing that computationally complex exercise as we speak today. But most of the blockchain networks have already moved on from a proof of work kind of consensus algorithm, and like it's looking at proof of stake. There are other consensus algorithms which is being looked at. So obviously quantum computing is going to disrupt that, but technology is going to evolve where there are other consensus mechanisms which will work along with quantum computing is going to evolve.
All right, fantastic. Thank you. Well, we're 2 minutes from ending, so I'd like to say a formal thank you to James and Asim. Really fascinating stuff. I still have to absorb a lot of that myself, but I guess I'd offer the participants, if you're okay with it, James and Asim, if they have any other specific questions we haven't gotten to today or that come to mind, they know where to get you. We will send out the copies of the slides and the video recording to participants. So I thank you for coming today. David's just put up a very brief poll. If you could answer that for us, that would be excellent. And I want to do a little pitch for our next seminar. Webinar will be the 21st of July, Essentialism Marketing Strategy. So that'll be fascinating with the 6 AM agency who have done some great presentations before. So thanks for coming and participating today, and a big thank you to James and Asim for Blockchain 101.
Thanks for the opportunity.
Thank you. Thanks, guys.